Yes, good evening to you all once again. I welcome you all another beautiful session of this control system subject. Today also I would like to explain one more example on given signal flow graph, and from that signal flow graph we need to find out the transfer function. Actually, the problem is like this. The problem is for the given block diagram reduction, we need to construct or we need to draw the equivalent signal flow graph diagram first, and from that signal flow graph we need to find out the transfer function. So by the way, today I am going to present the lecture number 14. It is lecture number 14, in which I am going to solve for you one important question. The question is like this. It is given this is input, this is given summer. From this you have gain G1. After that you have one more summer. From that you have G2. From then you have G3, means gain G3, and then you have one more summer. From then this is your C of S, this is your R of S. Okay. However, all the input signals, means these arrow marks, by default they are given by plus sign. Okay, they are with plus sign, and then from you have from the last summer, from this point 2 you have gain G4 is given, and it is going to this summer with plus sign. Sometimes remember that this plus sign can also be represented inside this summer here also, or sometimes it can be represented here also. Okay, nothing wrong in that. And after G2, from this point, after G2 means from this point you have, there is a feedback network with gain H1. This is H1, and this H1 is going to connect to this summer itself. This is going to here only with minus sign. This is with minus sign. From G2, means after G2 it is connected to this summer with minus sign. Okay, and from here it is connected to this summer like this with plus positive feedback. Okay, and then you have after G3 means from here you have one feedback element, and that is coming to this summer actually here with the negative sign. What is this gain? It is H2. This is sorry. So this is the given block diagram. Okay, this is the given block diagram. So for this you are asking that draw the signal flow graph. The question is this: draw the signal flow graph and find out C of S by R of S. That is our question. This is the given block diagram. For this you need to draw the signal flow graph first, and then we see what is the ratio of C of S by R of S, which is nothing but our required or desired transfer function. So let us go into the solution part for this question. Let us go for the solution part. Okay, then before going to solution part, just I would like to inform you that again, before going to draw the signal flow graph, you just identify the nodal points or nodes which are available in the given signal, in the given block diagram. As I have explained in the previous example in the last session, each input and then output and all the takeoff points, this connection is called as takeoff point. This is one takeoff point, this is a summer point, this is another summer point, this is the takeoff point, this is also takeoff point, this is summer point, this is output point. Input and then your output, and then take all the takeoff points and all the summing points are denoted by nodes, or you just how many nodes are there then. So in order to identify the nodes, it is better to note down RFA. So the input, start from the input. You consider the RFS as one node, starting node, that is node number 1. Next, immediately after input RFS, there is a takeoff point, consider that as node 2. After summing point, there is after this takeoff point, there is a summing point, consider this as the third node, is it not? After this summing point, what is the next point? Again summing point is there, consider this as fourth node. And after 4, what is there? There is a takeoff point, consider this as a again node, that is fifth node. And after 5 and after fifth node, what is there? There is another takeoff point, consider this as sixth node. And after 6, after this takeoff point, what is there? Summing point, consider this as your seventh node. And then after 7, finally your output C of S, consider this as also you must denote with node point and consider that as 8th node. Therefore total how many points are there? 8 points are there, means 8 nodes. Therefore now you need to draw the signal flow graph with respect to these nodes. Okay, then I will draw for you the signal flow graph. Let us carefully observe. This is the solution part I am going now. The solution. Okay, how many nodes are there? 8 nodes. Therefore, you just uh, let us say 1, 2, 3, 4, 5, 6, 7, let us say 8. So this is your 1, 2, 3, fourth node, fifth node, sixth node, seventh node, and then eighth node. Is it not? So the first node is obviously your R of S, and the eighth node is your C of S. Clear? Then, then now look at this diagram first. From node 1 to node 2, R of S means between first point to second point otherwise. Point 1, point 2. What is there? There is a straight line only. There is a single line is there. But this line is nothing but it is the part of this arrow mark which is going towards C of S. It is the portion of this entire path. Therefore, the direction of this path which is available between 1 and 2 is also towards positive direction only, forward direction only. Therefore, in between these two, simply line is there. But so here you draw that line and put the arrow mark in far by representing in the forward direction. You represent like this. You have to represent like this. Okay, and what is the gain for this line? If nothing is given, therefore consider the gain of that path is 1. Similarly, is it not understood? So if nothing is there in between 1 and 2, then consider the gain for that path is 1. Clear? Then again come to this point number 2 to point number 3. What is there? Again it is a line, and you draw that line between 2 to 3. Draw that line and show that arrow mark should be forward direction. And what is the gain? Nothing is there, therefore you just mark as 1. Similarly, 3 to 4. 3 is nothing but this summer point, 4 is another summer point. Between 3 to 4, what is the gain available? It is G1. Therefore, between 3 to 4, you need to draw with forward direction, towards forward direction, G1. The gain is G1. Is it not? So it is going to forward only. Therefore, you have to represent with forward. And what is the gain is nothing but G1. That is what G1. Between 3 and 4. Now coming to 4 to 5. So this is the fourth point. This is your fifth point. This is the takeoff point, this summing point. No problem. So in between these two, what is the gain available? G2, and the arrow mark is towards forward direction only. Therefore, between 4 to 5, you just draw a line showing the arrow mark towards forward direction, and the gain is simply it is a G2. Is it not? Similarly, between 5 and 6, what is there? Between 5 and 6, the gain G3 is there with the arrow mark towards forward direction. Therefore, between 5 and 6, it is forward direction, gain is G3. And then between 6 and 7, between this takeoff point and then this summing point, simply arrow mark is there, line is there. Therefore, you just draw a line and represent what is the gain. It is a line. There is nothing is given on this line. It is nothing but 1. And again from 7th to 8, finally it is a line to, and with a forward direction, and the gain is 1. That is what the representation for this straight path from R of S to C of S. Now coming to the other portion. Say for example, from point number 2 to and this G4, this gain from point number 2 to it is going to where actually it is going to the 7th point. Therefore, you draw from this point number 2 to 7 point with gain G4, and by representing the arrow mark towards forward direction, it is going forward. Means from 2 to you draw like this 2 to 7, it is reaching to 7 with arrow mark, forward towards forward direction. What is the gain? G4. G4 is the gain actually. So from 2 to zero point 0.7, it is going towards forward direction and with the gain G4. That is what the representation in the signal flow graph for this path. Now this path is completed. Now here let us come to this point here. From this third point, the arrow mark is coming. From where it is coming actually? It is coming from fifth point. Let us see carefully here. From fifth point, there is a feedback loop actually. It is a feedback loop with gain H1. After this H1, one point is connected here. From this one point, it is connected to the summer point with negative feedback. And from here, one more connection has taken, and this is going to be connected in this point number 3, summer 3 with positive feedback. Means from fifth point, the feedback gain is H1, and this H1 is connected to here, and the same H1 is connected to here also. Okay, so let us see that the connection is after H1 only. So here the connection is after H1 means what is the meaning of this? So you can represent this H1 is coming to here, as well as this H1 is also coming to here. Okay, likewise, how to represent then? From 5 to 4 means from 5 to 4 you draw like this with arrow mark reverse direction, because arrow mark is reverse, like this it is in reverse direction arrow mark is. Therefore you represent like this, where it is going minus to minus sign. Therefore you can represent minus H1. Similarly, from fifth point, it is going to the third summer with positive, having the loop gain as H1, feedback loop gain as H1. Means 5 to 3, you have one more connection, 5 to 3. From 5, you have up to 3. What is that? H1 means plus H1. This is plus H1. Understood? Okay, plus H1. And now, so this portion is completed. This loop is completed. Now what is remaining? This one, this from 6 to, it is coming with the negative direction, I mean reverse direction, to this fourth point, means 6 to 4. 6 to 4 means this is sixth point, and then reaching to fourth point with the reverse arrow mark, and it is coming to minus. What is the gain? H2. It is nothing but your minus H2. So this is nothing but the representation of the signal flow graph for this given block diagram. This is the representation of or equivalent signal flow graph for this block diagram. Now I will erase this diagram. This is not required now. So one part is completed, means representation of signal flow graph for this given block diagram is completed. Now let us see what is the transfer function. What is the transfer function for this? Let us see. Now I will explain here in very brief, because I already explained you in detail in the previous lectures. Therefore quickly I will try to explain this. So now we are going to solve the transfer function for this signal flow graph. As we have seen, step 1. What is the step 1? Step 1 is nothing but number of forward paths available for the given signal flow graph diagram. Number of forward paths, nothing but, so the paths from origin, nothing but from your input R of S to the output C of S. So if you see from R of S to C of S, there is a straight forward path with complete arrow mark in the forward direction only. Therefore this path you directly can consider as a first forward path. Means that is what your P1. That is what your P1 means, first forward path. That is the first forward path. Means in step number 1, we are looking for number of forward paths with path gain. That's you know already. Number of forward paths with path gains. So what this is the first forward path. Therefore, that is what P1. And what is the path gain? Path gain is nothing but 1 into 1 into G1 into G2 into G3 into 1 into 1. All gains must be multiplied. Then finally, obviously, what we will have? G1 into G2 into G3. Nothing but G1, G2, G3. Because multiplied by 1. Nothing but this only, no? That is our first forward path. What is there any other forward path? Yes, there is one more path is available. So from input 1 to point 2, and from here if you see, there is a arrow mark going forward direction G4, reaching to this point and reaching to final point. Means this is the path. Means this is the path like this G4. Therefore, that is what your second forward path P2. And what is the path gain for this path? What is the path gain? That is nothing but 1 gain 1 into this gain G4, and then here this gain 1 means 1 into G4 into 1. What is that? G4 only. That's all. These are the two forward paths available in this. Other than these two, is there any forward path? Forward path means in that path you must have forward direction only. You must have forward direction only. You should not have the reverse direction. Is it not? Therefore, only two paths available in this signal flow graph as far as this problem is concerned. This completes your step number 1. Now, come to the step number 2. What is the step number 2? The step number 2 describes about the number of individual loops, means L1, L2, L3 and so on and so forth. Number of individual loops we are looking in the step number 2. Now, go and identify how many loops are there. If you see from point number 3, just see from point number 3, it is going forward direction up to 4 and 4 to 5 and 5 to again it is reaching to 3. Therefore, it is forming one loop here. Understood? This is forming one loop here from 3 to 4, 4 to 5, 5 to again coming back. Therefore, this is what your loop 1. This is what 3 to 3, 4, 5. Okay, and from 5 it is coming back again, reverse direction. Therefore, that is what your L1. That is the first loop L1. What is the gain? G1 into G2 into H1 plus H1. Therefore, G1, G2, H1 plus H1 means G1, G2, H1. That's all. That is your path gain, loop gain of the first loop. That is the first individual loop you can consider. Okay, then go for the, is there any other loop? Is there any other loop available? Yes, definitely. Start from 4, 4 to 5 and again 5 to 4. It is ending here. This one, this is your second loop. This portion is your second loop. This portion means what is the gain? G2 into H1 minus signature is there. Therefore, minus will come here minus G2 into H1. G2 into H1 is the second loop. Okay, this is the second loop. Is there any other loop? Is there any other loop available? Yes, there is one more loop also. Let us see at point number 4. Point number 4 to 5 it is going forward direction. 5 to 6 it is going to another forward direction. From 6 to again with negative feedback H2 it is reaching to 4, means it is this one. This is the another loop actually. Therefore, that is what your loop number 3. What is the loop number 3? G2, G3, H2. Minus is there, no? Minus will come here. Means G2, G3 and H2. See how easy it is? Minus signature, minus sign is there. Therefore, you have to write here minus. Other than so, this is the first loop we have seen. This is the second loop is, and this is the third loop. So, there is no other loop actually. Only 3 individual loops you have. So, there are 3 loops. That is what your step number 2. Now, coming to step number 3. Coming to step number 3. What is the step number 3? What we will see in this? In step number 3, normally it describes or it states about number of non-touching loops. I mean 2 non-touching loops and 3 non-touching loops are available in the signal flow graph. Is there any possible, or is there any possibility of available of 2 non-touching loops and 3 non-touching loops and 4 non-touching loops and 5 non-touching loops and so on and so forth? Non-touching loops we have to start. Non-touching means minimum you need 2 loops at least, because if you have only one loop, there is no question of non-touching loop. There is no meaning of non-touching. Non-touching means must be two required at least. Then only non-touching will comes into picture. Therefore, in the step number 3, we have to look for, is there any possible combination of available of two non-touching loops, and then after that 3 non-touching loops. Okay, let us see. This is the loop number 1. By the way, you have 3 loops only, as we have seen in step number 2. You have 3 loops, and this is your loop number 1, L1. This is your L2. This is your L3, and all these 3 loops are touching to each other. L1 is touching to L2, and both these two are touching to this also. All are touching to each other. Means there are, you can write for step number 3, there are, you can write there are no, there are no 2 non-touching, what? 2 non-touching and 3 non-touching. 3 non-touching loops available for the given signal flow graph, for the given SGF. There are no 2 non-touching and 3 non-touching loops available in this. So finish, your problem is over now. Now come to the last step, that is the step number 4. Step number 4 is nothing but, normally in this we have to find out the transfer function using the Mason's gain formula. So as per this formula is nothing but by substituting the step number 1, step number 2, and then step number 3. By substituting these 3 steps in that 4th step, you will be getting your answer. Therefore, for the 4th step, so this diagram is not required, because so this signal flow graph is required for step number 1, 2, 3 only. For 4, for step number 4, you have to identify, you have to solve that transfer function with the help of these 3 steps. Now I am going for step number 4. What is step number 4? Directly using Mason's gain formula. What is? Using Mason's gain formula. Mason's gain formula, we have to find out the transfer function is equal to TF is equal to, it is C of S by R of S, and final this is equal to 1 by delta sigma K is equal to 1 to N and P suffix K delta suffix K. This is what Mason's gain formula. This is the Mason's gain formula. Here K is equal to number of forward paths. K is equal to number of forward paths. How many paths are there for this given signal flow graph? 2 paths. Therefore, K is equal to 1 and 2. Therefore, K is equal to 1 to 2. Therefore, you substitute at this K initially 1. Therefore, this can be written as, this is equal to 1 by delta. Now I can write like this. So it can be expanded like this. P1 delta 1 plus P2 delta 2. Understand? Likewise, P1 delta 1 plus, because summation is nothing but expansion, means summation nothing but plus P1 delta 1. Substitute first K value as 1, because for first forward path, P1 delta 1. Okay, then plus what is second forward? For the second forward path, P2 delta 2. That's all. Two forward paths only available. Therefore, you will have this much only. Now, So if you substitute all the known values, you know what is P1 here. What is your P1? P1 is nothing but this one, G1, G2, G3. What is the delta 1? Delta 1 is nothing but, by considering the first forward path, delta 1 is nothing but, delta 1 is nothing but, delta 1 is the value of the delta with respect to forward path 1. Okay, how to identify, how to find out the value of delta 1? So in order to find out the delta 1 value, consider the first forward path P1. Okay, by considering the first forward path P1, you just see that is there any non-touching loop is available with respect to the forward path. Okay, with respect to the first forward path, is there any availability of non-touching loop? That means that we have L1, L2, L3 basically for this problem, and in fact L1, L2, L3, all these three loops are touching to first forward path, means there is no non-touching loop with respect to forward path. There is no. Therefore, in this case, as all the loops are touching to the first forward path, then in that case, simply delta 1 value becomes 1. Therefore, delta 1 value is 1. Okay. Similarly, what is P2 here? P2 is nothing but this one only, G4 only. Okay. Then P2 is G4. You know that. And then what is delta 2? What is delta 2? I will explain here. What is delta 2? Delta 2 is nothing but the value of delta, is it not? What is delta 2? Delta 2, how delta 2 can be obtained? Delta 2 is nothing but, now consider your P2, I mean second forward path. As we have seen, you just observe your signal flow graph. So you have G4 means starting from RS, from node number 2 to, it is directly going to like this 7 to 8, G4 means for this path all these L1, L2, L3, all these three loops are non-touching to this forward path. Understood? So here what is the condition with respect to that particular path, if any loops or all the loops are non-touching to that path, then you will have the value of delta. Or otherwise, if all those three loops, if touches to the forward path 2, again like P1, then in this case also delta 2 is 1. But carefully see that for this P2, L1, L2, L3 are not touching, means they are non-touching loops with respect to P2. L1, L2, L3 are called non-touching loops with respect to P2. Then what we should do? In this case, you will get delta 2 value. What is delta 2 value? So in this case, delta 2 is equal to 1 minus sum of loop gains. 1 minus sum of loop gains. Yes, sum of loop gains. This means that this implies delta 2 is equal to 1 minus L1 plus L2 plus L3. That's all. This is what delta 2 value. Okay, further 1 minus, what is L1? This one only, G1, G2, H1. G1, G2, H1. What is plus L2? L2 nothing but minus G2, H1. And what is L3? Minus, therefore you will have minus here, G2, G3, H2. That's all. This is whatever. And if you finally simplify this, 1, this you multiply with this minus to this inner product, inner parameters, inner this thing, then 1 minus G1, G2, H1, you will have minus into minus plus, means you have G2, H1, again minus into minus, you will have plus here, means G2, G3, H2. This is what your delta 2 value. Understood? Understood? How to find out delta 2? Means for the next second forward path, by considering or with respect to the second forward path, is there any non-touching loops are available in that signal flow graph? Yes. Yes. With respect to this second forward path, the loops which are there, basically L1, L2, L3, three loops. There are three loops. These three loops are not touching to this. In this case, in this type of case only, corresponding delta value will be obtained, and this is what that will be identified like this, that will be obtained like this. This is what your delta 2. So you know delta 2 now. What is delta? So you know everything, no? P1, you know, P1 is this one. Delta 1 value is 1. Delta 1 value is 1 because all L1, L2, L3 are touching to P1. That's why delta 1 value is 1. P2 again G4. Delta 2 is nothing but this much. And then what is delta? Delta is equal to, again delta formula is same only. What is delta actually? Delta is nothing but 1 minus sum of individual loop gains plus product of, means sum of the product gains of all possible combination of two non-touching loops and then three not like that. Therefore, for this given problem, there are no two non-touching, three non-touching. Therefore, your delta is also almost all equal to this one only. Means delta is equal to 1 minus sum of loop gains. Nothing but same only. This is what your delta again. This is what this value is nothing but your delta. Therefore, substitute all this in this formula. So what you will get? What you will get? Let us see. Let us see. Let us see. And final simplification I would like to finish for you. So finally, if you substitute in the final step, that is your transfer function becomes like this. Transfer function is equal to, okay, it is nothing but C of S by R of S. This is equal to P1 delta 1 plus P2 delta 2 by delta. Is it not? This implies, what is P1? P1 is equal to G1, G2, G3. Delta 1 value is 1 plus what is P2? It is G4. Okay. Then what is delta 2? Delta 2 is nothing but what we have seen. Delta 2 is nothing but 1. Is it not? 1 minus, we have seen. So 1 minus G1, G2, G3 plus G2 H1 plus G2 G3 H2. This is whatever delta 2 by delta. What is delta? Delta is nothing but 1 minus sum of loop gains, means again L1 plus L2 plus L3. L1, let us say L1 plus L2 plus L3. Okay, this is minus. Next, what it will come? Plus terminal will come. What is plus term? Here, sum of product gains of all possible two non-touching loops, if they are available, minus sum of product gain of all three non-touching loops, because we don't have any two non-touching, three non-touching. Therefore, there is no question of this. Therefore, you don't have any. So you don't have anything in this case. There are no two non and three non-touching. Therefore, what is delta then? 1 minus this much only. Your delta is nothing but 1 minus sum of individual. So again, this is nothing but 1 minus L1 plus L2 L3. This is nothing but same as this parameter only. Is it not? Same as this parameter only. And then what? Means it is delta is equal to 1 minus, is it not? 1 minus, what is that? G1, G2, G3 plus same G2, H1 plus G2, G3, H2. That's all. That's all. This is what your transfer function. This is the final answer. This is the answer. That's all. This is your answer. Likewise, so how easy it is, how beautiful it is. Therefore, likewise, you have to be asked in your examination to find out or to construct the signal flow graph for the given block diagram, and from thereby you will be asked to find out the transfer function. I think you understood this, and with this I would like to close this session, and will be continued in the next session. And I request you all to please post your comments, and if you like, definitely like it, and you can even subscribe to my this channel, that is Electronics for Excellence, and you definitely can share to your friends also, and don't forget that to give your feedbacks, whatever it is. Definitely it will be it is it will be considered, and it will be addressed also. Okay, so that it will be good even for me to improve for you. Okay, so again, like as you have seen the feedbacks, if you give your feedback, and it will be good for me to improve for the sake of your growth and for your excellence. Okay, so I so with this I would like to close today's session. So thank you one and all.